Next comes a very important and a major source of internal noise, which is called thermal noise. It has got many names. One more famous name is Johnson noise. We have already discussed this a little bit before. We know that in every conductor there are free electrons which are always moving in random motion even when no external electric field is applied. This random motion is due to the thermal energy which they received from the surrounding. The distribution of these free electrons within a conductor at any given instant of time is not uniform because of this random motion. They keep on moving randomly in all the possible directions. The movement of electron gives rise to an electric pulse of current. If you measure the overall average current, it will be zero because there are large number of electrons moving in all the possible directions. But at certain given instant of time, it may result in a non-zero overall current pulse, and that gets added to the signal of interest, and this gives rise to nothing but the thermal noise. It is possible that an excess number of electrons may appear at one end than the other end of the conductor, and the average voltage resulting from this non-uniform distribution may be zero. But as we just now said, that the average power, when you calculate the average power, it may not be zero at specific time instant. At this power results from the thermal energy, it is called thermal noise. The thermal noise power can be calculated using this simple formula, which is KTB, where K is Boltzmann's constant, T is temperature in Kelvin, and B is nothing but the bandwidth of interest, the bandwidth over which we are measuring the noise power. It can be easily made out that if you increase the bandwidth of operation, then the more noise power will be present. If you increase the temperature of operation, then the noise power will increase again. That is simply because the thermal noise is due to the thermal energy. If the temperature increases, then the thermal energy will also increase, and hence the thermal noise will increase. Hence, this equation indicates that a conductor operated at a finite temperature can work as a generator of electrical energy, which is in the form of noise. The thermal noise power Pn is proportional to the noise bandwidth and conductor temperature. One last type will be high frequency noise. Now this is something opposite of low frequency noise. High frequency noise will be present at high frequencies. If the time taken by an electron to travel from the emitter to the collector of a transistor becomes comparable to the period of the signal which is being amplified, then the transit time effect takes place. Please remember that the time taken by electron to travel from emitter to collector will be very less in case of transistor. Now, if this time becomes comparable to the period of the signal, that means the period of the signal also has to be very small. And when we say that the period of the signal is very small, this will be the case only when very high frequency signal is applied to the circuit. So for very high frequency signal, the period of the signal will be small, and hence the period will be comparable with the time that electron takes to go from emitter to collector. And this effect is observed as it is observed at high frequencies. Due to the transit time effect, some of the carriers may diffuse back to the emitter. This gives rise to an input admittance, the conductance component of which increases with frequency. So as the frequency increases, this noise will also increase. The minute currents induced at the input of the device by the random fluctuations in the output current will create random noise at high frequencies. Once this noise appears, it goes on increasing with frequency at a rate of 20 dB per decade. But most of the times, if you are amplifying modulating signals, information signals which are of low frequencies, then high frequency noise may not come into picture. But yes, in communication system, especially when we amplify the modulated signals which are always of high frequencies, then transit time noise is also one source of noise that needs to be taken care of.